In this video, we're going to review polynomials, and in particular, we're going to pay attention to their end behavior. But first, we want to have some vocabulary under our belt. So let's take a look first at the general form of a polynomial. In the general form, we're listing our exponents in decreasing order. So here, our highest exponent, n, is a whole number, and in general form, we go down by 1 for each exponent. And then in front of each of these terms, these a's are simply the coefficient. So what we're really interested in here is what is the degree and leading coefficient of each polynomial. So let's start off with our general form. And in our general form, it's this very first one. Our degree is n, that highest power, and our leading coefficient is the number sitting in front of x to the n, which is a sub n. In our next polynomial, we see that our highest power is sitting right here, so our degree is 4, and our leading coefficient is 3. Now, we would have had the same answer even if this polynomial had been written like this. It doesn't matter what order we write it in. What matters is what's the highest power. We see that in this next example as well. Our highest power comes in right there, so our degree is 2, and our leading coefficient is -1. In the next one, it is written in standard form. And even though we don't have all the terms, we can see that the highest term has a degree of 3, or the polynomial has a degree of 3, and the leading coefficient is 3/5. And in the last polynomial, we have just one term, therefore the degree must be 12, and our leading coefficient by default is -3.2. Now, why do we care so much about the degree? And to take a look at this, we're going to pull up a spreadsheet, and we're going to consider what happens as we square and cube and take numbers to the fourth and watch how they grow. You might learn a few things about a spreadsheet along the way. For instance, if I enter in a set of patterns like this and then fill down like this, there we go, I've got the numbers 1 through 25. What I'm going to do in this next column is square those numbers. In Excel, I use the function power, and I'm going to say we'll take this number and square it. So I've done that. 1 squared is 1. And if I go on this little box here and double click, it fills everything down. And these are all of those numbers squared. So down here I have 25 squared, which is 625. And we can see when numbers are squared, they grow much faster than when we're going up by 1. In the next one, I'll do similarly, power. Take this cell to the third power, and I'll fill down. And what we'll notice is, 4 and 8 aren't that different. 27 is a fair bit bigger than 9, but when we get down here and we're cubing these numbers, and I'm nowhere near infinity right now, I'm just at 25. 25 squared is around 600. 25 cubed is at 15,000, which is a whole lot bigger. Let's take a look at this with x to the fourth. Same idea. We take this to the fourth, and there we go. We'll fill it down, and we see that now we're up at 390,000. Now, the whole point of this is that when we have this degree of x to the fourth, it's going to grow so much faster than x cubed, x squared, or x, or any term smaller than it, that it's going to determine how fast the function grows. And as you head to infinity, it's this x to the fourth that's going to determine the growth, not the other terms in the polynomial. All right, so let's just take a look at how that relates to this graph right here. These are just power functions with a single term, and you'll notice that, for instance, right here, x to the sixth, look how fast that was going up, whereas in comparison at the same height, x was going this way, and x squared, and we can see they're all heading to infinity, but x to the sixth is heading up much faster, so it grows much faster than any of these other ones. All right, so let's take a look at this. When we have end behavior, we're going to have terminology that looks like this. And when we see this, we would read this as x approaches infinity, f of x, which is the same as y, we would say y approaches, and that's what we're going to be answering. What does y approach? This next line just says as x approaches -infinity. Same idea. All right, so let's take a look at a couple examples. And we're going to grab the graphs of each of these and take a look at what happens. So if I go in here and I generate a graph of this function, I'm going to just drag it over here, we can see that we've got an even degree. And as x approaches infinity, we can see that this is heading up as well. So as x approaches infinity, f of x also approaches infinity. Let's rearrange our work here a bit. So, and then in the same way, as x approaches negative infinity, take a look on the other side. Oh yeah, we're still going up on both sides. F of x also approaches infinity. All right, let's take a look at another graph and see if everything's the same on this one. So this one is also an even degree because it's x to the fourth. We're going to grab its graph and bring that over here. And we'll notice, oh, that doesn't look like an x to the fourth, does it? So I think I know what I need to do though. I just need to zoom out. There we go. That looks more like an x to the fourth graph. Sometimes we have to play around with our window to make sure we're seeing the whole picture. All right, so on this one, as x goes to infinity, we notice that, oh, f of x goes to negative infinity. And as x goes to negative infinity, we're down on this end, f of x goes to negative infinity as well. Well, what was different about this one? And we should note that our leading coefficient was negative this time, and so that's why it was heading down to negative infinity. All right, so now we need some odd degree examples. So let's take a look at this one right here, and we'll grab a graph. All right, so we've got a nice graph, x cubed plus 1. And we'll notice that with this odd degree that the two ends don't go in the same direction as with the even, they go in opposite directions. So this one here, as x goes to infinity, f of x also goes to infinity. And as x goes to negative infinity, f of x goes to negative infinity right down here. All right, let's try another one. See if anything different happens here. And we will generate our graph again. There we go. And in this graph, oh, we see we're going the opposite ways. And because you're so quick, you're noticing, she had the leading coefficient as negative again. So this time, as x goes to infinity, we see that f of x heads to negative infinity. And then as x goes to negative infinity, our graph's actually going upwards. F of x is heading to infinity. Great. So we can generalize this, and it really doesn't matter. I gave you specific examples, but these things are always true. If I have a positive leading coefficient as x goes to infinity, f of x goes to infinity, whether it's even or odd degree, but as x goes to negative infinity with an even degree, it's going to go up in both directions, and anything can happen in here, but it's going to go up on both directions. With an odd degree, it's going to do opposite things, and so while I'll go up here, I'll go down here, and anything can happen in between there. All right, so if we have a negative leading coefficient, as x goes to infinity, f of x goes to negative infinity in both cases. But if it's even, it goes down on both ends, and if it's odd, it does the opposite. And so here we have with that negative leading coefficient, if I'm even, we're going down on both ends, and whatever we want can happen in between. And then for an odd degree, it's going down here and up here, and anything at all could happen in between here, although it should look like a function still. All right, so here we've got one last problem here, and I want you to take a look at this, our mystery polynomial. What's our degree, and what's the leading coefficient? Now, the first thing hopefully you're thinking to yourself is this is odd, because it goes up there and goes down there. Second thing perhaps is, oh, you notice that it's going down as your x is going to infinity. That would imply that my leading coefficient is negative. And then if you remember back to pre-calc, you would have done this and looked at how many times you went up and down. So that's 1, 2, 3, 4, 5. And that makes sense because it's odd. So my degree is at least 5. All right. Good luck on your homework having to do with polynomials and end behavior.